Triangles. Let us move on to a new topic, inequalities of a triangle. So here is a theorem. If two sides of the triangle are unequal, then the angle opposite to the longer side is larger. Now first of all, I need to consider a triangle. So let this be a triangle. Let me name this triangle. Suppose triangle ABC. Let me take three sides of this triangle. Let side AC be say 15 centimeter. Let side AB be say 9 centimeter. And let side BC be say 12 centimeter. Now, if two sides of a triangle are unequal, then the angle opposite to the longer side is larger. If two sides of a triangle are unequal, so if you observe this properly, there are three sides basically. This triangle has three sides, AB, it has BC, and it has AC. Clearly see that AB is 9, BC is 12, and AC is 15. So which is the longest side amongst these three? First of all, they say if two sides of a triangle are unequal. So if I compare AB and BC, can I say they are unequal? Yes, they are unequal because one is 9, other is 12. Then if I compare BC and AC, can I say both of them are unequal? Yes, BC and AC are again unequal because they are 12 and 15. And again if I compare AB and AC, can I say they are unequal? Yes, again they are unequal because 9 and 15. So if two sides of a triangle are unequal, indirectly means it is a scalene triangle. It indirectly means it's a scalene triangle. So if two sides of a triangle are unequal, then angle opposite to the longer side is larger. So which is the longer side over here? You can say that AC is the longer, or you can say it is the longest side. So which is the angle opposite to AC? The angle opposite to AC is angle B. Therefore, angle B will be the longest angle. Angle B has to be the longest angle, as AC is the longest side. Again, which is the smallest side over here? The smallest side is AB. As you can clearly see, AB is 9 and AB is the smallest side. Which is the angle opposite to AB? The angle opposite to AB is angle C over here. So angle C has to be the shortest angle over here, because side opposite to angle C, that is this AB, is the shortest side. Therefore, angle C is the shortest angle, and then which side remains? BC remains. So BC actually lies between AB and AC. Its length lies between AB and AC. Therefore, this angle A, which is opposite to BC, will lie between this angle A will lie between angle C and angle B. So angle B is the longest angle. That is, angle B is greater than angle A, and angle A lies in the middle, which is greater than angle C. That means we got this angle C as the shortest angle, which is opposite to the shortest side, and we got this angle B, which is the longest angle, which is opposite to the longest side. So indirectly you can remember this theorem as angle opposite to the longer side is larger and angle opposite to the smaller side is smaller. I'll give you one more example. Let me consider a triangle, say triangle PQR. In this triangle PQR, the length of the sides are given. Now we are supposed to identify the longest angle and the smallest angle over here. So first of all, we'll try to write down this in ascending or descending order. Which is the largest side? PR is the largest side over here. Then, which is the side slightly smaller than PR? You can say PQ. Then, which is the side smallest in this triangle? QR is the smallest side in this triangle. Let me write down their lengths respectively. PR is 12, PQ is 10, and QR is 8. We know that the angle opposite to the longer side is larger. So which is the longest side over here? PR is the longest side over here. Which is the angle opposite to PR? The angle opposite to PR is angle Q. So I can say that angle Q will be the largest angle. Then which is the angle opposite to PQ? If this is PQ, angle opposite to PQ will be angle R. So angle R will follow PQ. And which is the smallest side? QR is the smallest side. So which is the angle opposite to QR? Angle P is opposite to QR. Therefore, we can say that this angle P is the smallest angle. Therefore, we have arranged the angles in descending order. So, angle Q is the longest angle, then comes angle R, and the smallest angle is angle P. Let us move on to the next theorem in inequalities of a triangle. In a triangle, side opposite to the larger angle is longer. In a triangle, side opposite to the larger angle is longer. Let us take an example. Let me draw one triangle over here. Suppose this is a triangle. Let us name this triangle. Let this triangle be, say, triangle ABC. In this triangle, the three angles are angle A, angle B, and angle C. Now, according to the given statement, in a triangle, side opposite to the larger angle is longer. Let us assume that angle B is the largest angle. Suppose angle B is the largest angle, then side opposite to the largest angle is greater. So which is the side opposite to angle B? Now this is angle B over here. This is the position of angle B. Then side opposite to angle B is AC. So AC will be the largest side. You can say largest side or you can say longest side. Similarly, we can modify the statement. In a triangle, side opposite to the smaller angle is smallest. It is one and the same. So side opposite to the smaller angle is smallest. Suppose angle A is a smaller angle amongst A, B and C. Then which is the side opposite to angle A? The side opposite to angle A is BC. So if angle A is smallest angle, then BC will be the smallest side. So in this way, exactly converse of the previous one, that side opposite to the larger angle is longer. Let me take one more example. For that I need a triangle. So let me consider a triangle like this. Let me name this triangle, say for example PQR. So here is P, Q and R. Let us take some random measurements of these angles. Suppose this angle R is 50 degree. Suppose this angle P is say 60 degree. And let this angle Q be say 70 degree. According to the given statement, we know that in a triangle, side opposite to the larger angle is longer. So which is the larger angle over here? Amongst angle PQ and R, we can say that angle Q is the largest angle. And since angle Q is the largest angle, which is the side opposite to angle Q? The side opposite to angle Q is PR. So we can say that this PR, that is this side PR, is the longest side. Similarly, we can also find out the shortest side over here, which is the smallest angle. The smallest angle is angle R. Therefore, we can say that shortest side will be side PQ. So PQ will be, you can say, shortest or the smallest side. So in this way, in a given figure, if the angles are known, we can easily find out which is the smallest side and which is the largest side. Now let us move on to the next theorem. The sum of any two sides of a triangle is greater than the third side. Sum of any two sides of a triangle is greater than the third side. So again we need a triangle. Let me consider this as a triangle. Again let us name this, say ABC. So it is clearly mentioned that sum of any two sides of a triangle is greater than the third side. Let us take some values of these sides AB, BC and AC. Let this AB be say 8 units. Let this BC be say 7 units. And let this AC be say 12 units. Now these are the three sides of a triangle. It is clearly mentioned that sum of any two sides of a triangle is greater than the third side. So sum of any two sides, that is addition of any two sides. Suppose if I add AB and BC. So how much will be AB plus BC? AB plus BC will give me 8 plus 7, and 8 plus 7 is going to give me 15. And this answer 15 will be greater than the third side. So which is the third side? The third side is AC. So this 15 is greater than 12. So we can say that AB plus BC is greater than AC. You can select any two sides simultaneously. Say for example, I select BC and AC. So if I do BC plus AC, how much is BC plus AC going to give me? It is going to give me 7 plus 12. 7 plus 12 is going to give me 19. And this will be greater than the third side. You can check. This 19 is greater than the third side, that is AB, which is 8. So we can say that BC plus AC is greater than 8, that is greater than AB. Similarly, if we move further, if we take AB and AC, AB is 8, AC is 12. So 8 plus 12 is going to give me 20, and 20 will be greater than the third side, 7. So a triangle is formed only when the sum of the two sides is greater than the third side. Say for example, AB is equal to 5 centimeter, BC is say 7 centimeter, and AC is say 18 centimeter. Now if I have these three sides and suppose I have to construct a triangle ABC, let us see construction of triangle ABC is possible or not. You can start with any sides. Let me start with the base AC. So suppose this is AC, 18 centimeter. So let me name this as AC. Now you can see that AB is 5. From this point A to B, it is 5 centimeter. So even if I draw 5 centimeter, it can be something like this. And BC is 7. It will be something like this, say. This is just an example. It's not the exact figure. Now if you observe properly, these 2 points are not meeting each other. These 2 points are not meeting each other. Why? There is a gap over here. Why this gap is there? This is because AC was 18 centimeter. AB is 5 centimeter and BC is 7 centimeter. But AB plus BC, if I do AB plus BC, how much is AB plus BC? AB plus BC is going to give me 5 plus 7. And how much is 5 plus 7? 5 plus 7 is 12. But this 12 is not greater than 18. So it is not greater than 18. Therefore, the triangle won't be formed. These two vertices won't be joined. Even if you drop them down on this line, B point will come somewhere over here and this point will come somewhere over here. This is a gap of 6 centimeters. Now why this is a gap of 6 centimeter? Because if I'm covering 5 centimeter over here and if I'm covering 7 centimeter over here, 5 plus 7 is going to give me 12. So a gap of 6 centimeters remain. So in this way, always remember, sum of any two sides of a triangle is always greater than the third side.